Welcome to Pre-Calculus Unit 2, Topic 2. So we're going to be going over some of the problems. So in number 1 through 4, solve the equations algebraically. Remember to check for extraneous solutions. Now remember, extraneous solutions are solutions that, in a sense, have you end up doing the whole problem algebraically, but then what ends up happening is when you plug it back in, it actually doesn't work. So we're going to be checking for those specific types of problems. So the first thing I'm going to take a look at is we're going to be working with the exponential equations. When we have common bases, we can add the exponents. So in this case, the 2 and the 2 are common. So I'm going to write this as 2x, and then that's going to be plus negative 2x is equal to still square root of 2. And then if I combine those, I get 2 to the negative x is going to be equal to square root of 2. Now, to solve this specific type of problem, I'm going to actually make it so that both of them actually have the same base. Now, since it is actually 2, I'm just going to rewrite this as 2 to the negative x is equal to 2 to the 1/2, right? Because that's another way of writing square root of, let's say, something. So it's 2 to the 1/2 power. Now, since they are both actually the same base right here, we can just set the exponents equal to one another. So negative x is equal to 1/2, and then x is going to be equal to negative 1/2. Now, just to double check to see that this is good to go, we're going to say 2 to the 1/2, actually negative 1/2, times 2 to the negative 2 times negative 1/2, and see if that, in a sense, is going to be equal to square root of 2. So right here, this is going to end up giving us 1 over square root of 2. And then this is going to end up giving us 2. And this is going to be negative times the negative is a positive, 2 divided by 2, which is 1. So I'm going to actually, you know what I'm going to do? Is I'm actually going to just keep it as 2 to the negative 1/2. I'm just going to bring that up a little bit. Okay, so since we have common bases here, we can we can add the exponents, so that would actually give us 2 to the 1/2, which is actually also equal to square root of 2. So that checks out. So my answer here is going to be x is equal to negative 1/2. Moving along, base to the answer is equal to the inside. I keep saying this in terms of logarithmic equations. So base, which is 3, to the answer, 2, which is equal to the inside, 5x minus 11. So I get 9 is equal to 5x minus 11. We're going to add 11 to both sides. So we get 20 is equal to 5x, divide both sides by 5, and we get x is equal to 4. Now our double check. So log base 3 of 5 times 4 minus 11. Let's see if that is going to be equal to 2. So log base 3 of 20 minus 11, which is going to give us 9, and that's going to give us 2 is equal to 2, and so that checks out. X is equal to 4. Number 3, since they both have a log base 3, we want to try and condense them together. The only way to condense them together is by making one single log, but then those two quantities, the 5 minus x and also the 5 plus x, they're going to be wrapped in parentheses and put together by multiplication, is equal to 2. Now we can do base to the answer is equal to inside. So base, which is 3, to the answer, 2, is equal to 5 minus x and 5 plus x. So if I FOIL this out, right, first, outer, inner, last, I end up getting 9 is equal to 25 minus 10x plus, actually that's not going to be 10x, that's actually not going to be there, so 25 minus x squared. I'm going to bring the 9 over. So if I bring the 9 over, I end up getting the following. 0 is equal to, so I subtract that, so it gives me 16 minus x squared. So 0 is going to be equal to 4 minus x and 4 plus x. So that means that my two solutions are going to be 4 and negative 4. By the way, this is just good old factoring, like if you have a minus b, right, they're both squared, I can write that as a plus b and a minus b. So another example would be like, let's say if we said x squared minus 9, we can write that as x minus 3 and x plus 3. It's just the order is kind of weird for this. That makes it really kind of different to see. So if I end up plugging in those values, the big thing here is making sure I don't get a negative value. And it seems to me that most of those, the 4 and the negative 4 are going to work. But let's work these out. So log base 3 of 4, not 4, 5 minus 4 plus log base 3 of 5 5 plus 4. Let's see if that gives me 2. Question mark. So I end up getting log base 3 of 1 plus log base 3 of 9. So this is going to give me 0 plus 2, and that's going to give us 2, so that checks out. Okay, so log base 3 of 5 minus negative 4, and then plus log base 3 of 5 minus 4. Is that going to give me, so that actually gives me the same set thing. I'm going to get 0 here, I'm going to get 2 here, so that's going to be equal to 2. So that one checks out as well, so both of them are good to go. Okay, last problem. Divide everything by 2. So the 2 goes away. I'm left with 5 to the x plus 1 is equal to negative 10. Add 1 to both sides, or excuse me, subtract 1 to both sides. I get 5 to the x is equal to negative 11. Then to undo this type of problem, I end up, to undo the 5, for example, I'm going to do log base 5 to both sides. Log base 5. Log base 5 to both sides. So I get x is equal to log base 5 of negative 11. Now, something kind of keep note, right? There is no value that you could actually get for log base 5 of negative 11. Normally, this value needs to be greater than, in a sense, 0. So that x value normally, well, it's not x in this case. We'll call this, let's say, a. So that needs to be greater than 0. If it is not greater than 0, should be the other way around. So if it is not greater than 0, then this is actually not a solution. So we would say that there is no solution. Now, you could technically call this an extraneous solution, but since this isn't actually even a real numerical value, it's not possible. And just to kind of confirm, if I did 5 to the x is equal to negative 11, can you think of a value that you could plug into x such that it will give you a negative value? And if you think about it, there isn't anything, so there is no solution to this problem. Okay, so this will be definitely a calculator problem. I'm going to be using Desmos to kind of help me along with this type of problem. So it says the temperature of a bowl of soup in degrees is located by this specific set equation, where T is equal to the time since it was served measured in minutes. So it says determine the temperature of the soup when it arrives. Use mathematics to justify your answer. So the temperature... So the temperature of the bowl in degrees where T is the time since it was served. So when it was served, that would be when T is equal to 0. So we're going to write S of 0 is equal to 76 plus 54 e to the negative 0.162 times 0. Now what's interesting here is that S of 0 is going to be equal to 76 plus 54, and this whole value right here is going to be e to the 0, which is technically just 1, so S of 0 is going to just be the addition of both of those values together, which is going to be not 90, so that's going to be 80, so that's going to be 130, and so most likely this is going to be degrees Fahrenheit. Okay, it says determine the temperature of the soup 5 minutes after it was served. So S of 5, right, because we're talking about time, and especially being minutes, 76 plus 54 e to the negative 0.162 times 5. Now you could just type this whole thing in your calculator. Since I don't actually have a good old normal calculator available, I'm going to use Desmos. So I'm going to write 76 plus 54 e to the negative 0.162 times 5. And so that should give me S of 5 is equal to roughly about 100.02 degrees Fahrenheit. So they don't say about any rounding, so I'm just going to round to 2 decimal places. So it says determine the perfect time in nearest minutes to eat the soup if the perfect temperature to eat it is at 115 degrees. Now we have some type of understanding that if it is at 0 degrees, it's 130. If it is at 5 minutes, it's going to be 100 degrees. So we know that the specific time is going to be between 0 and 5. Now the only way to actually do this is by graphing this equation. So y equals, and then instead of using 5, I'm going to use x. Now, it might be kind of difficult to kind of set up your graph, so you might have to do a little bit of window adjustments. Also, kind of keep in mind if this is 150, I know that the y value is going to be, in a sense, in 150 range, so maybe go up to like 150, 200. So we can see my graph right here. If I have my window x is set from -10 to 10, you actually don't even need to worry about having it set to negatives. And then the next one I'm going to do is I'm going to do y equals 115. And you want to actually do the same exact thing when you're on your TI-83 or 84 calculator. And you want to look for that specific intersection. So there is my intersection. So use mathematics to justify your answer. So you would say the intersection. Of S of t and 115 degrees Fahrenheit is at time 2.009. And since we're talking about minutes, that's going to be minutes. And don't worry about converting from minutes to seconds or anything like that. Just say 2.009 minutes. All right, then says, as time tends to infinity, the temperature of the soup approaches the room temperature. Determine the temperature of the room. Use mathematics to justify your answer. Okay, so with this, it's one of those things that you want to try to figure out, in a sense, what are these values possibly going to? So we can see here that if I remove that, and it won't let me grab. Okay, so I can keep moving these values so that it gets closer and closer to some type of temperature. So let me tap that graph again. So it looks like that's getting closer and closer to 76. Now you can do this on your calculator, but you can also do this in terms of the table. So it's getting closer and closer to some type of value. In this case, it's getting closer and closer to 76, which in a sense is that first value. So which means that this is in a sense getting closer and closer to 0, while this is the only thing that is left over. So that would be 76 degrees Fahrenheit. And you can explain that by saying that you're looking at the table, you're looking at the trace values, and realizing that the Y value is getting closer and closer to 76, so that would be the room temperature. Okay, there's been an outbreak of a certain virus in Maryland. The number of infected individuals is currently 25 and increases by 6% every day. So it says write a function v of t that gives the number of infected individuals after t days. So since it is a specific number of time, we're going to do the following. So we're going to start off with the number of infected. So that is actually, so let me actually go back a little bit. So we're talking about 25 people that are infected. So we're going to start off with 25. That's our initial amount. And then that multiplies each day by 6%. So how to set that up? We're going to write this as parentheses. We're going to write this as 1 plus 0.06 because it's going up by 6% each day. The 1 is just using that initial 25. And then we're going to say raised to the t power. So that is v of t. It's very similar to the compound interest or the simple interest problems, where we would say the amount is equal to principal times 1 plus the rate to the t power, where the principal in this case is normally my starting amount. In this case, that's going to be my 25. And r is going to be my rate, which in this case is the rate of increase, and then t is acting as my time. So, on which day of the outbreak will the number of infected individuals exceed 1,000? So we're going to write this as 1,000 equals 25 parentheses 1 plus 0.06 and then raised to the t power. So what I'm trying to do is I'm trying to solve for this specific equation. So I can divide everything by 25. Yet again, you can use your calculator to help you figure this out. Just set the equation equal to this and then set another y equals to that. But I'm going to do it by hand because, well, it's fun that way. So I end up getting 40 is equal to 1.06 to the t power. Now to undo this 1.06, I'm going to do log. Whoops, that's not the one I want to do. So I'm going to do log base 1.06 to both sides, log of 1.06. And this is how you would do it mathematically, algebraically. Now if I'm doing it graphically, I'll show you what that looks like in a second. So I'm going to write this as y equals 25 parentheses 1.06 and then raised to the x power. So there's my nice little graph, and I'm going to write y is equal to 1,000. All right, let's take a look at the graph. Now, yet again, keep in mind, right, this is supposed to be 1,000, so you're going to adjust the window to be some values. So I'm going to get t is going to be equal to 63.308. And what does that mean after 63.308 days? That's when the number of infected will exceed over 1,000 individuals. Will this model result in a reasonable answer when t is equal to 1,000? Will this... Well, let's see. What happens when I actually type in 1,000 here? When I type in 1,000, let's say for the x value. Okay, so there's 1,000 for the x value. Whoops, 1,000. 1,000. Okay, so where is this graph going to be at 1,000? Well, we can kind of see right here, right off the bat. So that's 5 with a whole bunch of zeros afterwards. And I haven't even gone halfway to get to that 1,000. So will it be a reasonable model? So that means that we're saying 5 with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're talking about, in a sense, million, so 50 billion people. Now, in the grand scheme of things, are there 50 billion people in Maryland? No. So even if we were to like exceed that even further, because it increases by 6% each time, that is not a large, or value extends to be way too much to even be the number of people in Maryland, hence even the number of people in the United States. So no, not a reasonable amount. Since I could just say, since there's not enough people, I'm just trying to shorten this video a little bit further. But okay, so actually I am finished. If you have any questions, please comment down below. Also, please comment on my Discord if you have any individual questions dealing with these specific type of problems. And thanks for your time.